Welcome to this explainer. If you just take a look around, the universe can seem totally chaotic, right? It's literally filled with this dizzying array of materials, reactions, and transformations. But we actually make sense of it all by taking this massive concept of matter and chopping it up into highly specialized branches of science. So today, we're going to decode the physical world by zooming in on the specific branches of chemistry.
Okay, let's dive into this. First, we'll quickly define what chemistry actually is, then we're going to explore physical rules and biology, take a look at environments and ecosystems, check out fireworks and spectrometers, and finally, wrap it up by connecting the sciences.
So, Section 1. What is chemistry? Let's establish our baseline.
Now, what you're seeing here is the exact source material we're decoding today. It's essentially a guide that lays out a series of descriptive questions mapping real-world phenomena right to their specific branches of chemistry, and we are going to unlock the answers to these mysteries together.
So what does the text actually say? It defines chemistry as the branch of science dealing with the properties, composition, and structure of matter. Crucially, it also studies the physical and chemical changes in matter and the laws governing these changes. I really want you to think about that for a second. Chemistry isn't just about mixing things in beakers in a dusty lab. It's the fundamental study of how matter changes and the actual laws that allow those changes to happen in our universe.
Moving on to Section 2, Physical Rules and Biology. Let's look at some mystery phenomena. Imagine the raw mechanics of the universe for a moment. What specific branch of chemistry dictates the speed or the rate of a chemical reaction? Or, pushing it even further, what branch studies the intense, high-energy properties of plasma? It's a bit of a puzzle, right? We're talking about the deep, structural rules of how matter behaves. Any guesses?
Well, the answer from our source is physical chemistry. This is the specific branch where both the rate of a reaction and the properties of plasma are studied. This branch really hones in on the foundational, fundamental rules of matter and the actual physics behind chemical behavior.
Okay, now let's totally shift the scale. We're moving from abstract reactions and plasma right into your own stomach. Who studies the digestion of food in the human body? Like, if you were to track exactly how the food you ate for lunch gets broken down into usable energy, what type of scientist are you?
You'd be working in biochemistry. As our text points out, the digestion of food in the human body is studied in biochemistry. It's super fascinating because we're applying those core chemical principles of matter and change specifically to living organisms. Actually, it's a pretty huge leap from studying glowing plasma to studying how we process a sandwich.
And this brilliantly illustrates just how incredibly vast the study of chemistry really is. On one hand, physical chemistry looks at rates of reaction and properties of plasma, these highly physical, abstract rules. Meanwhile, biochemistry focuses on human digestion and organic processes. They're looking at entirely different types of matter, but they are both rooted in the exact same fundamental science.
Let's zoom out a bit for Section 3, Environments and Ecosystems. We're talking macro scale now. Our source text prompts us with a truly massive phenomenon, the ecosystem. How on earth do chemists study something so sprawling, complex, and interconnected? When you're dealing with whole forests, oceans, and atmospheres that are all constantly interacting with one another, what do you even call that field of study?
The text gives us the answer right here: environmental chemistry. This is the specific branch dedicated entirely to the study of the ecosystem. It's absolutely crucial for understanding the incredible chemical changes in matter that are happening all around us in nature at a massive scale every single second of the day.
All right, Section 4, Fireworks and Spectrometers. Let's turn the explosive energy up a notch.
Think about a massive celebration. The sky is dark and suddenly, boom, brilliant colors explode across the clouds. What type of chemistry is actually responsible for those loud, spectacular reactions taking place during fireworks? Which branch handles this incredibly exciting, highly visual transformation of matter?
No surprise here. It's inorganic chemistry. According to our guide, inorganic chemistry deals specifically with the study of reactions taking place during fireworks. It's all about those rapid, dramatic chemical changes that release immense amounts of energy and light, giving us those spectacular shows we all love.
Okay, let's take a deep breath and step out of the loud, chaotic world of exploding fireworks. We're going to drop the pace down and get highly precise for a minute. Our final phenomenon from the text asks about the measurement of the absorption of wavelength with the help of an ultraviolet spectrometer. So we're now talking about measuring the unseen.
Now, what's really interesting about this is that analytical chemistry deals with exactly that, the measurement of the absorption of wavelength using an ultraviolet spectrometer. It literally allows us to detect and measure phenomena that are completely invisible to the naked eye. It's basically the ultimate toolkit for figuring out exactly what matter is made of at the absolute most precise levels.
Which brings us to Section 5, Connecting the Sciences. Let's summarize the journey we just took.
So the crucial point is how all these wildly different phenomena are beautifully categorized here. The rate of a reaction and plasma, that belongs to physical chemistry. Digestion maps straight to biochemistry. The vast ecosystem is the realm of environmental chemistry. Explosive fireworks fall under inorganic chemistry, and precise UV wavelength absorption is analytical chemistry. It elegantly organizes the absolute chaos of the physical world into 5 neat branches.
And yet, despite the crazy differences between eating a burger, shooting off a firework, or measuring invisible light, it all ties directly back to our foundational definition. In every single one of these examples, chemistry is studying the properties, composition, and structure of matter. It's tracking the physical and chemical changes and uncovering the specific laws that govern those exact changes. The whole shebang.
It really makes you look at the world a little differently, doesn't it? Which brings me to a final thought. If analytical chemistry can measure wavelengths we can't even see, what other invisible changes in matter are happening all around you right now? Keep that in mind as you go through your day. Thank you so much for joining me for this explainer, and definitely keep your curiosity alive.